Karen Greenhouse. Thank you for joining us this evening. We are just starting with these webinars, so we're excited that we have some of you joining us, so that is great. Just a quick little brief intro to who I am. I am an educator, have been a math educator for over 30 years, high school, middle school, college. I've worked in publishing, lots of different things. I teach at Drexel currently, but I also work with Casio, so I help with creating tutorials and videos and lessons, and I work with Amy helping train teachers and speak at conferences. So that's sort of my role with Casio, and I'm very excited to be able to be doing these webinars. And Amy is with me as well, and so I'm going to let her introduce herself.
Hello, thank you guys for joining us. As Karen said, I work at Casio. I'm the training and product manager. I've been working with educators as a math educator for 14 years. And at Casio, I am in charge of scheduling and coordinating workshops for schools and districts and at conferences, and then working with our development team on calculator updates and improvements as well. We will ask everyone to kind of keep themselves mute. If you have a question, as Karen mentioned, we'll use the chat panel to ask the questions. And then if I need to stop Karen, I will do that. Otherwise, I think we're good to go.
Okay. I am going to switch my screen to the Classpad.net. So if you saw when you came on, I said if you want to play along, go to the Classpad.net page, and we're going to walk through a couple activities. I'm going to share some activities in the, or actually Amy's going to do it for me, but in the chat panel. But we're all going to start on this page right here, Classpad.net. And if you're new to Classpad.net, I'm not really going to go through it. This is not a tutorial necessary. We've had a couple previous webinars where we went through how to sign up for an account, how to share papers, all of those things. So if you want to find more about that, go to our YouTube site, which we'll show you at the end, and you can watch our pre-recorded webinars from before that go through all that. What my goal for today is I really wanted to focus on different ways you can help students explore linear relationships. So I am going to be showing you and going through some of the functionality. We're going to do scatter plots and tables and do sliders. So we're going to learn a lot of the things that are in Classpad, but we're going to do it through the lens of linear relationships. All right, so we're going to start with we're going to collect some data from you. So right now I'm on Classpad.net. If you want to play along, please feel free to. You do not have to. You can just watch. These are recorded. You can look at them later. But here's the landing page. I'm going to scroll down, and I'm just going to go into the Start Exploring. I don't have to have an account. Students can do this. You can do this. So when you hit Start Exploring, it just opens up a practice page, or a guest page, as we like to call it. And you can play on this and do whatever you want on it, and it's completely free. However, the difference being, if you want to save what you did, you do need an account. So I'm going to kind of show you that briefly. So here we are. So if you're playing along, we're going to go into, and I can click anywhere. So I'm going to just click somewhere. I'm going to go get a table. So if you're playing along, just go to the data, and it's going to pull up a table. And we're going to ask you to send us some information. We're going to collect data. So this is a great way to use this tool with students, especially in this remote learning environment where a lot of times we're doing things online with students. You can actually collect data through the chat, or however, do a poll ahead of time and do it. But we're going to collect some data here. So I'm going to ask all of you to send in the chat your height in inches and your shoe size, because I am going to make an assumption that that might be a linear relationship. As your height is increasing, your shoe size is also increasing. So for me, I am 67 inches tall, and I have a shoe size of 9.5. Yes, I have very large feet. So if you guys, if I just want a couple things of data, if people will just send me in the chat just your height, and Amy might need to read those out.
Sure. We have a height of 60 inches.
Okay. And so all I'm doing is I'm clicking on, so those of you playing along, just clicking in the table, and I'm tabbing over to the B column to put in the shoe size. So I got a 5.
5, yep.
Okay. Next.
We have a 68 inches.
Oh, 68 tall.
And 10.5 for shoe size.
10.5.
We have a 67 with a size 10.
All right, so I'm not the
We have
only one with large, and I probably I should probably be doing male versus female, but at this point we're just gonna, it's fine. So
Yeah.
anything else? What else?
69.
69.
With the shoe size of 9.
Okay.
We have 68 for the size 10.
And
here, throw in mine 64 with the 7.5.
Okay, so you can collect as much. So if you were doing with students, this would be really fun. They could all add in there, and there's lots of things you can collect. So I'm just going to move this. If you're new to Classpad, we call these stickies, and that means I can stick them anywhere. So I'm going to put this over here because I know I'm about to make a graph. So this is a table, and I want to make a scatter plot to see if I do actually have a relationship between height and shoe. So to do that, I'm selecting the column. So I'm going to select column A, so you see how it shades in, and I'm going to select column B. So A is going to be assumed as my X value, and B is going to be assumed as my Y value. So as I do that, notice I get this soft keyboard that comes up, and this is the statistics options that you have. And there's a lot of things I could do right now. So I could do regressions, tests, intervals, but we're going to go to graph. So when you click graph, here's all the possible graphs I could make from this data that I have selected. I want a scatter plot. So all I have to do is click it, and it automatically makes my scatter plot. Oh, we have some interesting data here. So I want to point out a couple things that happen here. So this is just kind of a descriptor of what my scatter plot is. It's telling me that the height is the X and the Y is the shoe size. And now here is my scatter plot. And notice it's doing kind of the an automated scale. I can zoom in just simply by clicking on the graph and moving my mouse if I actually want to see all the way to 0. Right now that doesn't make sense. I can also go up here, 3 dots in Classpad always means settings, and I want to actually change my axes to be what they are. So this was height, right? So that's always something nice to do with students, is to label their axes so that they know what each thing represents. So you'll see that those now appear. There's the X and there's the Y. All right, so sort of linear, right? Would everyone agree we sort of have a linear relationship here? We have a couple of interesting scattered points here. But now what could you do with this? Well, if I were working with students, I would want them to maybe, at this point, can you find the slope? Can you pick some points and figure out what might be a good line of fit? So to do that, I'm going to use the calculator. And the whole point of this session today is to show you how you can interconnect all of the different options in Classpad. So I'm going to get a calculator out. So I'm going to click over here, and notice calculator is my first option. So I'm going to get a calculator, and I want to, at this point, I'm going to assume students know how to find a slope if they have a set of points. So I'm going to just choose, I'm going to look at my points here, and notice when I click on them, the coordinates of them come up. So that's kind of nice. So I kind of like that point, and I like that point. So I'm going to use those 2 points to determine my slope. And in the calculate, notice soft keyboard comes up. And if I had, a touch screen or something, I could be using the soft keyboard. I tend to use my own keyboard, but I'm going to use the soft keyboard right now. So I want to find the slope. So I want to do, change in Y over change in X. So I know that I'm going to kind of want this standard notation. So here's the points I've chosen to use. So I'm going to do change in Y. So 10 minus 7.5. And then the change in my X will be 68 minus 64. Now, here's where I'm going to make a change. So notice my answer is in decimal, and I am still in as a guest. And so I can't toggle to a standard notation because I am a guest. So I'm going to do something where you don't have to do this. I'm going to do something real quick just to show you the difference between the answer when I'm just a guest and when I have an actual account. So to do that, I'm just going to go up here, 3 dots, and log in real quick. Oh, I don't want to log in as me. So bear with me. What is it? There it is. I don't know why it doesn't come. All right, so it's gonna, I want you to notice what happens. So it doesn't look like the paper changed at all. Everything's the same, but up here now I have this cloud. And if you're still in as a guest, you don't have that. This means I'm now in my account and all this work I'm now doing is being saved automatically, which is awesome. But I also want to show you the difference. So remember, I did this calculation, but now because I'm in at the account, I have full access to everything. I can now toggle between a standard forms fraction versus the decimal. And I'm dealing with slope, so I kind of want to use this one. So that's just a real quick, why would you get an account? Because you have access to a little bit more of the features and it's auto saving. So now I have my slope. So now I want to go to my graph, and we started with the table, but now I can do another representation and create a function, right? So I'm going to get my equation sticky, and again, notice I can move it wherever I want, where it makes sense. And I'm going to enter what I think is a good equation for this. And here's a really nice way to help students understand what form of the equation. I know it seems to be a linear relationship, so I want a linear equation. Which form makes sense? And it really depends on what you have. So what do we have right now? We have a slope that we were able to figure out based on the points I chose. And we also have points, but we don't have the y-intercept. So the slope-intercept form doesn't make sense here because I don't have the intercept. I don't have any point that's crossing. In fact, my y-axis is way over here because I'm here at 60. So that form doesn't make sense. So what form does make sense? Well, I have points. I have points and a slope, so maybe the slope-intercept, or I'm sorry, the point-slope form makes sense. So let's now pick a third point to use as our point in my equation. So I'm just looking at my picture here, and I'm going to say, well, this one looks like a nice one. So that's the point I'm going to use. So here's my equation. I'm going to use it in the form. So y minus the y point that I've chosen, which is right here, 5, equals, and I could be using this down here. Why don't I do that? And I want my slope, right? So I'm going to put my slope in. So 5 over 8 is my slope. And then I'm going to do the x term, so x minus 60. Right? So this is the equation that I've come up with. If you're working with students, they could have chosen different points, right? So they might have different equations, and we could all see which one fits the best. So we're going to hit execute. And it looks pretty good, except I have kind of these interesting points laying out here. So how do we talk about those types of things? So here's where you can now do something extra. Here's my line of fit, and other students might have different lines of fit for the same point. So now we can do a regression. So we're going to go back to our table, and I just want to show you some of the other statistical things you can do. So I'm going to select my 2 columns again, and notice up here I can do 1 variable statistics, 2 variable statistics if I want, but what I want is a regression. I kind of want to see how well my line that I came up with fits this linear regression. So I'm going to choose that, and I want you to see what happens. And we'll just move this kind of out of the way. So it's telling me this is the linear regression. Notice the linear regression is in slope-intercept form. And here's the regression, and it's not exactly the same as mine, right? So this is a really nice exploration for students. They can come up with their own line, then they can compare it to the linear regression, and they can maybe adjust theirs if they think they need to, or if they're happy with theirs, that's fine too. So I wanted to just start with this activity just to show you how easy it is to collect data, do scatter plots, do some calculations, and I'm doing them all in this one place. So before we move to the next activity, are there any questions? So Amy, please stop me if there's something I need to answer before we move on.
No questions so far.
All right, so the next 3 things, well, I have 3. We're probably not going to get through all of them. Hopefully Amy's keeping me on track here with time. So the next couple activities are activities that are ready to use, but I chose them because they're going to highlight some other cool features of Classpad.net, like sliders, for example. So we're going to go into a new activity. So Amy, I believe I sent Amy the link. So these are pre-made activities that have been shared publicly, and there for anybody to use who, even if you don't have a Classpad.net account, you can use them as long as you have the URL. So I have those publicly available to share, and Amy's going to send you the link, and I'm going to go to it right now. So here is this activity. So this is an activity just ready to go. You could use it with your students, and I chose it because I wanted to show you some other things that you can do with the graphing. So in this last one, what did we do? We did table, we did plotting an equation, we did some regression. So in this activity, what I'd like to highlight is, if you notice, there's an image in here. And so you can add real world images into the graphing sticky and the geometry sticky of Classpad.net. And so this is a graphing sticky. And if you look down here at the bottom, there's this image. And so all I did, I'll just show you what it looks like, is you click here, you find a picture that you like, and you can upload it. You can have more than one picture in each of them, and you just kind of change where they're centered and their size. But this image right here is this one, and so I moved it, I think, so that it would line up. So this little arc, or this little bridge holder, was right on the y-axis, which is why it's at this -0.2. So you can play around with where the central location is. So that's adding images. So now what do we do with an image? Well, now this is a great kind of activity for curve fitting. So I need some points to put on this, right? So that the students can figure out what equation they want to use. So the next thing that you can do on a graph is plot points. So we put some points on in the last activity by entering them into a table and making a scatter plot. This is different. This is actually, you're just going to plot some points and then you're going to be able to move them. So if you've opened this activity, all we're going to do is click this plot points, and it brings up a table. And 3 dots again, I can change the color of the points. And so if I'm looking at my picture here, it's kind of blue. I probably don't want blue points. So I'm going to choose black so that my points will show up a little bit nicer on my grid here. And so now what points do I enter? Well, it doesn't really matter because I'm going to move them around. I'm just going to enter some points that I know are going to be on the screen somewhere. So my domain and range are kind of important. So I'm just going to enter random points, and I'll show you why it doesn't really matter. So hopefully you're seeing, so I entered a point at 1, 2, so you should see it showing up right here. It's in black. And I'm just going to enter a bunch of them at the 1 mark because I'm going to be moving them anyway. 4 points we do. So here's my 4 points. They're where I plotted them. But the nice thing is once I click on them with my arrow, I can move them anywhere. And notice in the table, it's moving as well. The value of that point is changing. So let's say I want the students to choose a line and come up with an equation for that line. So I'm going to choose this line right here. So I'm going to put a couple points on that line. So notice as soon as I drop them, the coordinates show up here for me, which is nice too. If I don't like the coordinates showing up, you can get rid of them by hitting this X. But I'm going to leave them there. They're working for me. So I'm going to just move the rest of them to where I think it fits nice. Here, we'll put it here. All right, and you can move this around if they're kind of in your way. There we go. All right, so I've got 3 points that I think fit in this line. And so the next step would be, okay, so what's an equation for this line? See if you can make it fit. And so we probably go through the same process here. If I was kind of estimating, I could even say that there's one that's on the y coordinates, the y-axis, so I could use that as my intercept, right? So let's do that. So now what have I done? I've plotted points, I've put them on my image, and now I'm going to come up with an equation that I think goes through that. So we're going to go back to our graph function here, and let's pull this where we can see it. And I'm going to change it to match the color of my points. So again, that's just clicking on this. And so now I need a slope, right? But I'm going to do it all in one equation. Instead of doing it as a separate calculation and then putting it in, I'm just going to do it in the equation from the beginning. So actually, let's move this up here a little bit. So I am going to do my y-intercept slope-intercept form. So I'm going to do y equals, and so I need my slope. So I need at least 2 of these points to represent my slope. So I'm going to choose this one and this one. So I'm going to do my slope by doing the change in y over the change in x. And I probably should put this in parentheses, but I'm not going to do that. Okay, so there's my slope. I didn't actually calculate it out. I'm just letting the equation figure that out later. And then I'm going to use my x, and I'm assuming that this point is on the y-axis. So well, it's pretty close. I'm off just a tad. Whoops, I didn't finish. Sorry, I went off. It thought I had finished. So I'm going to say it's plus 4.46, close enough. So now when I do it, it looks like it's going through the line. The next thing I want to show you is because does it make sense that this line is continuous, right? So in theory, no, we only have part of a line. So I wanted to show you how you can also limit your input, your x value or y value. So if I look at this and I ask the students, does it make sense that this line is continuous? For this bridge example, no, I only have this piece of a line really on the bridge from, looks like -10 to the 0. So I'm going to limit my domain, and that's pretty easy to do. I'm going to go back to my equation, and I can either do it on the keyboard or I can go into math, and you'll see this little, I don't know what we call that. Amy, does that have an official name? The straight up bar is what I call it, but I don't
Have the bar.
the bar. So that bar, and it's also on your computer keyboard. But if I click that, that's basically telling Classpad that, oh, we're adding some limitations in here. And so I'm going to limit the domain, right, the input. So I'm going to say -10. So I want -10. And then I'm going to get my less than or equal to, and then x. So x is going to basically be between these two values. And so I need my less than or equal to it again, and then 0, because I'm going to assume this, it sort of stops right here at the y, right? So when I hit execute, watch what happens to my line. I only see that little piece of the line. So this is a nice way for students to practice not only finding equations that fit curves, but also understanding that there's limitations sometimes. You don't need all of the values. Continuous doesn't necessarily always make sense. And you could now, if you want, have them plot, you know, if this was what you were doing as practicing, you could get more plots, and each one comes in a different color. So you could have several different lines up there that they plot points and try to find equations to fit. So there's lots of things that you could do with that. So I'm almost ready to move on. I just want to make sure, did I go too fast? Is there a question about anything that I've done? I'm really trying in this session to kind of show you all the different ways and representations you can have students thinking about linear relationships. Anything, Amy?
Nope, we're good.
Okay. So the next activity is going to be showing off the ability to use sliders and use sliders to show and help students get an understanding of what those coefficients in equations do. So Amy also has the link for this, and we will make sure all the links are shared at the end, like in a follow-up email that we'll send you, so that you don't have to be hunting around for them. But actually, let me go back to this. If you do have an account and you want to save these activities, because right now, if you notice, I'm actually working as a guest in this activity, which is what you all are probably doing if you're playing along. But since I have my account open, I can actually save the work I've done by simply, well, it doesn't realize, why is it asking me to log in again? That's interesting. Here, I'll show you what to do on this one just because I don't want to have to log in again. When you have worked and you're a guest, if you click up here, you'll see this duplicate button when you're in your account. If you're in an activity that was shared, like these are being shared with you, if you just click that, it makes a copy in your account. So then you have that activity and you don't have to recreate it. It's just there for you to work with. And it's your own version of the activity, so it doesn't impact my version or whoever created it. It's your version now that you can do anything you want, add to it, modify it, delete stuff. So that's what, if you like what you're doing, that's what you would do with these activities. Sign into your account and duplicate them, and then they're yours forever. So let me move into the next one. So the next one is a little different. Again, it's a ready-to-use one, but it has a lot of interactions. So this is really about function transformation and understanding where those equations come from, like the slope, intercept, the standard form, the point slope form. So it's using sliders. So if you've never worked with sliders before, they're just a way to basically see change as you are moving. So if you notice, this right now starts off with the parent function of a line, so y equals x. And there's some questions built in here, and you'll notice that in some of these pre-made activities, the questions are in one color that kind of match the banner, and you can change colors, you know, up here, and you can change colors in text up here, 3 dots. That's a way to change the colors. But if you're thinking about using Classpad to work with your students, when you're creating activities, you can have directions in one color and a place for the students to write their answers in another, so that they kind of get in the habit of, oh, here's what I'm supposed to do, and here's where I write my answers and my observations and show all my work type of thing. So that's how these are sort of set up. So this is a line, the parent function. This is going to stay here, and they're asked to make some observations. What is the slope? And hopefully at this point they understand that the slope is 1. But then the next thing they're asked to do is, okay, in this red line, I want you to type in y equals a. So instead of a number where we would normally put, you know, a slope, times x. So it looks very similar to the parent function, except for this variable that represents some unknown number. So when I hit enter or execute, notice what happens. Because I used a variable, it creates this slider, and it graphs a function. So it's graphing a line at the current value of a. So the current value of a is a -10, and this is what the line looks like. And so right away they're going to say, well, it's different from the parent function because there's a different number in front of here, right? Now, before I actually start moving the sliders, I want to talk about what's in a slider. So in the slider, you have, you know, your range. This is the default is -10 to +10. You can change this to be, you know, whatever. I think there is a limit. I feel, Amy, do we know what the limit is? It's pretty big.
I don't know, actually.
I feel like it's, I don't know. I'll have to test. But I could change to 1,000, 100, 1,000, whatever I want. And actually, that's probably way too big. Well, we'll leave it at that. And you can also change the step. So the step is how it's going to move. So you could move by decimals if you want, which means it's moving very incrementally, very small amounts. Or you could, for instance, in this particular case, I'm really trying to help students understand what that A coefficient does. And what it represents. So I don't want to use decimals because they're not going to see the changes much. So I'm going to choose a step of 1. So I want whole number here. So that means, so now what I'm going to ask them is, let's just hit this. And so see, there's this little arrow here. That's an animation button. So one way to start off is just to animate so they can actually see it moving. It's moving pretty fast. And what's happening. So it kind of gives them a, what's going on with this? What is that A value doing to the line? And it's, I probably went way too big here, but you know, I'm going to stop it. I'm going to change my numbers. They're kind of silly. It's almost too big. I went too big. So let's change it a little more realistic here. All right, let's try that again. So the idea is, oh, it looks like A is making the line change its tilt, but it's still staying at 0, right? Like it seems to be anchored at that 0. So then let's stop it and let's explore. So the next question might be, can you make this second equation, the red one that's controlled by the slider, line up exactly on the parent function? And, you know, so I actually know how to do that. But if I move it to 1, oh, it's exactly the same. So when A is 1, which represented the slope, remember we already talked about that, then it's exactly the same as the parent function. Well, what would happen if it's negative, and have them come up with these you know, suggestions? So then they move the slider manually, and if I do negative, oh, it becomes tilted in a different direction. So you're exploring what that one coefficient is doing. And so when you finally have this understanding that that coefficient represents the slope, and negative versus positive, what is a 0? What if it were 0? What would that look like? And that's a vertical line. So there's a lot of things you can discover just from using the sliders. So then the next step is, okay, so we figured out what A does. A represented the slope, and that's how that's changing the line. So let's now compare, let's do a different coefficient. Let's do y equals x plus b. So this time I left the slope as 1, as same as the parent function, but now I'm adding in this other value here, a constant. And notice I'm going to get a second slider here. So same idea. You can explore, you can change the step. We probably still want a step of 1. And as you move the slider, you can, like, when is the green line exactly the same as the, you know, the parent function? And that's when it is, oops, I guess I didn't do a step of 1. Now let's try it. There we go. And just any of you familiar with other tools that have sliders, one thing we are working on, Classpad is very, very new still, and they're still working on some improvements. And so one of them is making the sliders be more more responsive in real time. Because if you notice, as I move a slider, it moves to its position after. And so where they're still working on, that's coming soon actually, where they're going to make the sliders be more responsive in real time. But they do move, you know, they move to their position a little bit after you've ended up there, which is why I like the animation thing, because then you can actually kind of see what's happening in real time. So as they're working with this, another thing to do is to click on the actual graph, and it shows those key points. And now, what is this key point? How does that relate to the slider? And so hopefully by doing that, they're going to make this connection that, oh, well, this is where it's crossing the Y, so that B must represent the interception, those types of things. So sliders are really great tools to kind of help students understand what those coefficients and those constants are doing in these equations that we make them learn. And obviously, this last one would then be to put them together and then have students, can you make it be a negative and cross at the 5, you know, just kind of explore. This activity, and I'm not, Amy, how am I doing on time?
You're good. We have about 15
I want to
minutes.
make sure we get into the other activity, I think. But I want to just show you. So this activity, it starts with the SlopeIntercept form, but then it comes down and you're going to go through the same process with the Pointslope intercept. So it actually has, here's the parent function again, and here's this line that has 2 points that are represented here. That's where the slope came from. And they're going to explore, basically, they move the line. And again, this is one of those things, it moves after the fact. So we're working on that. But they're going to make new lines and write the actual equation. So this is kind of showing them the form, but then now move this line and write the actual equation with those current points so that we can see, and then they get to move the line again. So it's sort of the same thing. It's not really sliders. This is a point that is attached to, I mean, a line that's made from 2 points, and you can move those 2 points. So it's a movable line. So that's another way to help students explore what's happening. And it makes sense instead of sliders because this is the point slope form. So we want points to help make that clear. So again, questions here, they have places they're going to write all these different equations. And then if we move down, here's the standard form. And this one has sliders as well and questions, and they are going to do the same type of thing observing. So this is a kind of an exploration activity where it's showing a lot of the different features of Classpad with sliders and movable points and lines, but it's already done for you, and you can just add to it, those types of things. So any questions before I move into the last activity that we're going to do?
No, wait, you're good to go.
Okay, so this last one is kind of a combination of different things. It's having students write equations. So you'll notice that there's, what am I trying to say? So there's a place they're actually writing them. And one of the things I want to point out about Classpad is these places where the students are asked to write math things like math equations or show their work. In a text sticky in Classpad, you actually can do math type. So in number one, it's asking you to write an equation and stuff, but you can actually use, so notice here there's one with a fractional slope. They don't have to put it in its decimal form. In the text sticky right here, this little button that's the square root of, I guess, alpha, creates these lines that bring up the math templates, the keyboard, the soft keyboard. So I could actually enter, well, actually, let's go back up here to 2. I can actually write an equation for a line that has a slope of 2/3 and a y-intercept. So I could actually enter this and have it look the way I expect it to. I can show the 2/3, and I think it was -1, right? So that is a really nice feature of Classpad, is you can actually do math type, and students can actually do square roots and absolute value in the work that they're doing. And so it's really nice that they have that. So this activity is actually doing a couple things. It's this right here. I want to show you the difference. This is a graph sticky. So if you know you're a graph sticky, because you can graph a function, you can put some data in, put an image in, plot points. This, while it looks very similar to it, when I click it, I want you to see the difference. This is actually a geometry sticky that in the 3 dots, I added a grid to and put an axis. So it's a geometry sticky, and the reason is because now we want students, before they actually graph anything, we want to test or assess, see if they can actually, they've made these functions, can you actually plot it using geometry tools? So they're going to, let's say we want to do this one right here. So I want a line, so maybe I even want to put my points in first. So I'm going to use my geometry. So I know I have an intercept at -1, right? So I'm going to go to -1 and put a point. So this is where students are using geometry instead of just using the calculator to have it graph the line. They have to actually show they understand what this slope and intercept actually mean. They're using the geometry tools. So now I need another point using my slope. So I'm going to go up 2 and over 1, 2, 3. So here's my second point if I'm a student. And now I can get my line tool, and there is the graph of that line. So a couple different ways that you could really help students understand, have them doing it themselves using the geometry sticky, because you can make the geometry sticky look very much like a graph with coordinates and all that stuff, and plot the points and the lines. So they do it by hand, but then you can come back down and actually have them graph all of the different functions here. And so in this activity, they're graphing these 3 different functions. We've given it to them, they're going to graph it, and then they're going to ask questions about it. What happens if it's comparing the slopes, and it's looking at what happens when there's 0, those types of things. So they get to change their graphs. So let's actually just graph them real quick. And one thing you could do is copy and paste. So that's a nice feature as well. So all I did was copy that. And so now when I hit it, there's that graph, and I'm going to do the same thing. So the nice thing, if you're in the text and you've used the math, you can just copy and paste without having to duplicate. And my last one. And what happened to my, where's my blue line? I don't know what happened to my blue line. Amy, thoughts? Oh, they're on top of each other, aren't they?
Yeah.
Interesting.
It didn't, the red one didn't copy over.
Oh, okay. That's it. Thank you. There, that's it, right? There we go. Whew. All right. So now they're going to explore that. And one of the things when you have multiple graphs, just since I'm here, let me show you another amazing feature of Classpad. So I've got, different graphs here. And when I click on any line or graph, it shows the key points, right? So I can see key points. And what I want to show you is if there's any points of intersection, notice the points show which lines that they lie on. So that's a really nice feature as well. And interesting. Oh, I'm in as a guest. If I'm not in as a guest, it'll also show me the standard form, so like the fractional form of that. But I'm still in here as this activity as a guest. But what I wanted to show you is you can find key points really quickly and easily. But let's say I don't want to see all these graphs together; it's too much, or maybe I just want to look at one of them by itself. Whenever you create graphs, each graph, so each one of these equations gets its own tab. So the tabs match the graph, right? So I have the blue line, the red line, and the green. If I want to pull them apart, I can do that very easily by clicking on the tab, and I'm holding my mouse down right now, and I'm just going to drag across. And now I can see the blue one separately, and these two are together. I could actually pull all three of them apart if I wanted to. And every time I do that, the associated equation goes with the graph that was pulled apart. And if I want to put them back together, I can either drag the graphs on top of each other or even drag the stickies on top of each other, and it will pull everything back together. So that's a really amazing feature. I love that about it. And another thing, once you're in the equations and you click on them, I can click here and there's a table. So at any time I can get a table of values. And if I click all of them, watch what happens. It just basically adds all of them together so I can see each one evaluated at that value of X. And you can change these values, you can add to them. It automatically defaults -5 to 5, but you can change these or add, like if I want to know what happens at 20, it's going to show me the result. So these tables are really nice. I don't have to see all of them. I can see just one of them, however I want to do it. And if I drag the graphs apart again, the table will go with it as well. So if I pull green out, I get the green table with the green graph and the green equation. So they all kind of stick together. And you can see they have these little, I call them spider webs, but it kind of shows you all the paths of things that are connected to each other. Right now, this looks like a jumble because I haven't been moving things down, but you have unlimited space in these activities, so I could keep adding on more and more. So that's the nice thing. You can do pretty much anything you need. You can do calculations, geometry, and graphing. So I think I'm done as far as just showing you. The whole idea of this session was to show you lots of different ways to help students think about linear relationships, while at the same time showing you a lot of features that Classpad can do. So I wanted to save the last few minutes, couple of minutes for any questions. I'm happy to show something again if you want to see it, or if you are curious about something that I didn't show and you want to see it, that's fine too. So I will open the floor for questions, and if there's no questions, then we will let everyone be on their way. So any questions, Amy?
Karen, can you open up a new paper?
Okay. Oh, well, now I'm in here as a guest.
Or go back to your own.
I'll go back to my own. I just want to, that's a great segue. I'm in here still as a guest. And again, I know that because there's no little cloud and there's no option for me to have a new paper. So I'm going to go back to where it's my account. So again, the difference, here's my cloud saving everything. And I now have the ability to create a new activity. So that's new paper. And all I do is click this and it basically puts this back in its folder. So it goes into my papers folder. And then I have a new blank screen that I can work with. So there's my new blank screen. What am I doing?
And can you show how you can pull up a geometry sticky note?
Sure. So you can pull up anything you want simply by clicking anywhere on the screen. And so you can pull up a calculator, which we saw in that first activity, the graph, which we've been doing a lot with, and here's geometry. So geometry, if I click this icon, pulls up this geometry sticky. And again, it can be moved, it can be enlarged, if you really want a lot of space to work with. I can go to the 3 dots and I can add in different types of grids. So a dot paper, isometric grid, minor grids, diagonals, lots of things I could add. I can have auto labeling on or off, those types of things. So geometry, here's all my tools. Here's all the things I can do with it, adjust. I actually have to have something. So this is a really cool feature, geometry. You can just draw something in it. Oh, I'm terrible at a circle. I'm sorry. It takes me like 50 times to do it. No, 2 times. But you can just start drawing and boom, you've got a shape, and then you can start doing things with it, moving it. And notice the minute I had some objects in here, I now have lots of things I can do. I can adjust it, measure angles, all these things I can measure. I can construct, all those types of things. So that's the geometry sticky. And that's described a little bit more in one of the previous webinars. We can actually go through each sticky and how they work. And then we have another webinar where we went through the settings of each sticky. Anything else?
Nope, I think those are all the questions that we have.
Okay. So again, the idea here was to simply show you lots of ideas of working with linear relationships and different ways you can use Classpad.net. So tables. What I love about it is it's so convenient for multiple representations. You can do tables and scatter plots and equations and writing all in one place. So that was sort of the whole intent. So the activities that we went through today all are free access. So if you sign up for a free account, accounts are completely free. And if you sign up for an account, you have access to them, and you have access to hundreds of other activities. I'm going to click here real quick. That paper, when you have an account, you have a place that basically saves all the work that you did. And so here's, I have mine in icon view. Here's all my papers and all my folders and things I've been working on. So this is icon view. You can kind of see all the work I've been doing, work with protractors and images. So you can save your things, but if you want to find papers, like the ones I just shared with you, they're in the public space, right? And you can search for them right within Classpad. You go up here and search keywords and get all that information. If you don't have an account, you can still find free activities, and I'll just do that real quick. If you go back to the home page that we started with, up here at the top are activities. And so these are free access, just like the ones we shared this evening, where you don't even have to sign in for an account. You just go to these activities pages and you kind of, if you're in a specific subject, so we were doing algebra today, this is all kind of focused on the calculate, but here's all these different activities that if I click them, it takes me to an activity that I can play with and explore. And if I want to save it, then I need my account. I really recommend that you guys sign up for an account. It's free and it's an amazing tool, and I use it all the time with my students at Drexel. So it's a great tool. You just share things by URL like we've been doing with you. So that was it. So thank you very much for spending the evening. I know you have lots of other options, and we really appreciate you taking the time to spend with us. And I'm going to share right now our social media sites. Amy, are those up?
Yes.
Okay. So we do a lot of, I've been creating math lessons every day. And so there's a lot of new lessons out there if you follow our blog. And we have a YouTube channel where there's a lot of how-tos and support, and we tweet every day if we have something new. So make sure you follow us. And then we also have, Casio in general has a Casio Cares, where we just have a ton of free resources, both calculator and Classpad.net. So if you're looking for resources for your students or for your teachers, that's a great place to go. And I'm done. Thank you again so much for joining us.